Just to recap, no, we covered design patterns. So basically, you may see the recording. I've also provided these notes also in the shared drive. And
Yes.
these are the two books which are interesting books for design pattern. If someone wants to learn design pattern, this is the classic book, the first book which coined the term design patterns. But yes, this is a little bit hard to read. And there is no programming languages specific examples, this generic discussion. But yes, this book is a nice book, which is easily understandable also with a lot of good examples as well. Right?
Yes, sir. Yeah, actually, I'm
Yes.
referring to this second book.
Yes, yes.
This one.
So this is
Yeah.
the second edition of this book. It had a previous edition also, which had a different picture, right? Yes.
Yes.
But yes, hope that yes, probably, yeah, in design patterns, there's nothing changed. Maybe they would have just revised it based on the feedback, or they might have done some error connection, etc. So yes, these are all I covered. But yes, what all we have covered so far in design pattern is we have covered all the creational design patterns. So this
Okay.
is all covered, right? So today I'm planning to cover the structural design pattern. So
Okay.
this
Yeah.
part,
Yeah. Sure.
which is facade pattern, adapter pattern, decorator pattern, composite pattern, and flywheel pattern.
Okay. Okay. Sir. Okay.
Yeah, let's start this. And yes, whoever will join, we will include
Yes, sir.
as the class goes. Oh, perfect. Yes. We'll be covering all these patterns. Yes. Let's start with the simplest pattern, which is the facade pattern. Okay, just give me a minute. Let me, yes. So, okay, sure. So let's start about just
Okay.
yes, we're just about to start in a few seconds. Yes. Yes. Great. Okay. So yes, no, we'll be covering today the facade pattern. So let me explain. You know what is facade pattern?
Don't have much idea about structural design patterns, sir. Sorry.
Okay, okay, sure, no problem. So facade pattern is a pattern. So basically, we'll start with what is the problem. So problem is sometimes you have a complex piece of software and there are too many functionalities. But yes, facade pattern is all about simplifying a complex interface. And if you have complex set of classes, so basically the pattern is something, no, assume you have lots of classes So let me draw this. So yeah, here you have classes. So in any component, you have a lot of classes, right? And you have a software, which is, this is a software or a component. Yes. So here you have software, and I will write here software with complex set of classes, right? So I am drawing few, but let's assume many and there are a lot of interdependencies and etc. Yeah, definitely. Now you'll have classes which will be associated with each other. Some classes packages will be there. So what we do in a facade pattern is we provide a simple interface. So how is this pattern actually working is you create a simple interface. So probably here, this is the facade. Yes. And facade may be having few uh, methods, right? So basically, you may have a facade which provides some interface. Let me draw some interface. Yeah, let's say this is our interface. So this is a simplified interface. So we can assume that you have here a lot of functionality. For example, let's say we have payment processing, which have lots of functionality features in this. And you have similarly other pieces. Say, for example, you have, say, warehouse management, right?
Okay, okay. So
And
notification services.
yes, you have some lot of complicated services in underline. Just I'm putting it so that it becomes easy. Say shopping cart. Just I'm giving some e-commerce application example, and you have say here product catalog, etc. Right. So and then there are many methods. So what you probably provide is a simplified interface to all these components. And this simplified interface may be having few methods, which is maybe say buy and right. So pay and so payment and yes, maybe few simplified methods, right? So let's say just these two methods are there. So this is all about facade pattern. So maybe when you call by method, so there is a client here. Client will be calling this. So instead of calling individual methods, it becomes very difficult for clients to remember all the functionality. So what they do is clients just call the facade interface, and facade interface will in turn ensure that it will call the appropriate method in the software with complex set of classes. So this is about facade pattern, very simple pattern, nothing complicated here, easy to implement, but yes.
Okay, so yeah, got it.
This is a structural design pattern which provides simplified interface. So I will just write down here the definition provides simplified interface. Right. So the problem is you have complex set of classes. You have a very sophisticated library, or it could be some framework. And then you ensure that when you make some call, make an in sequence. Here, another thing which you can understand is maybe when you say buy, there is happening is when you say buy, you provide the product detail, right? Maybe product ID you provide, and then inside it will do check stock, right? This the step one, and then maybe second is check price. Okay, apply discounts or offers, right? And then there are a lot of maybe activities here. Calculate amount, right? So these are various things and various things which happens in sequence. And then finally you have something like, say, check payment status. So this is what may be happening in the background. So we provide a simplified interface which will take care of complex set of classes, lot of logic, as well as it takes care of also various sequence of methods. And now client need not have to worry about calling all these methods in any. Now they will call just by method. This will take right. So this is all a facade pattern, right?
Okay, so it provides structure to complex architecture.
These are the methods. Yes, yes. Right. So this is your pattern, and yes. So the business logic, probably here now we also discuss what all solid principles comes into picture. So when you apply facade pattern, you are anyway getting tight coupling, right? And then yes, in facade you get abstraction. So definitely you have a lot of solid principles or object oriented principles which comes into picture. Definitely it's all about abstraction. It is about hiding the unnecessary details and only exposing simplified interface to the clients. So that's there. Then you have coupling. Tight coupling is achieved here, right?
Right.
Uh, right. And then it actually simplifies development, basically. So that is the main benefit. So there is not many benefits available here. For example, code reviews, etc. is not applicable here. What it provides is a easy, simplified interface, which is making your complex application developer friendly. Yes.
Okay.
So yes, Arun and Ramesh, do you know about facade pattern?
Yeah, I have seen people using in my company a lot of times, but not sure completely. But
Correct.
I'm just thinking it's just like if you have a service and that is the entry point to the like kind of controller.
Yes,
Just
yes, right. So yeah, so here you have a facade. Facade is a new interface. So this is what I kind of shared an example here. So basically, yeah, I should name this also interface as facade interface, right? Yeah.
So this entire architecture provides tight coupling, right? Because all the processes are, all the interfaces are interdependent.
Right. Right. Yes, absolutely. Right.
Like, sorry to ask, like I just joined.
Yeah, Suresh.
Yeah, this is Arun. I just joined. Could
Okay.
you like quickly tell in 1 minute like what has discussed? Sorry.
Yes, yes. So we were discussing structural design patterns, and we are covering various patterns. So first pattern which we covered so far was the facade design pattern, right? So the facade design pattern is all about simplifying interface. So providing a simple interface. So here example is you have a lot of classes. I have drawn few, but yes, assume there are a lot of classes and they are interdependent, and there are a lot of dependencies. Maybe they are also using some external libraries, and there is a complex piece of logic, right? So what this client will, if have to utilize the functionality, if it has to call the functionality, it will be a nightmare for clients to implement different kinds of UIs. Assume you have various client applications that needs to be developed on this backend framework, which is being provided, right? So let's say we are getting to develop more clients. So here we have web client. So you see here the functionality needs to be called in multiple ways, right? And then there could be more clients, which could be, say, I would say a desktop client, right? So yes, here for application developers, it would be a nightmare because they would have to say, assume these are the developers who has to develop these clients, right? So it would be it will be nightmare for them to ensure that the users are able to buy a product, because I said buying a product will involve checking the stock for the product, then checking the price for the product, right? So it involves a lot of other methods or business logic, and they have to be taken care in a specific order, right? So there may be much more complicated logic which would be there. So the buy method is providing very simple interface. It takes care of calling all these dependent methods in a specific order, and clients need not have to worry about all the complicated interface which is underlying in the application. So this is about facade pattern. Is most simplest pattern of all the design patterns, I would say, right?
Uh, uh, you mean like in the facade pattern, we will have logic for all the basically orchestrating all the API calls?
Yes, yes, right. So yes, if you have to write the code for this, so basically just to give you some example about how the code will look in this pattern. So you may say that, yes, you have lots of classes. Say we have product class, right? So I'm just, yeah, it has a lot of code, right? And then you have class, which is, say, shopping card class. Yes, again, assume it has code. Then similarly, you have other classes as well, which is payment processor, right? Again, lot of code is there, lot of methods are there, right? So yes. And then we have another class, which is, let's call, we call this is easy by, right? Say, this is what my facade is. This, what we can do is we may have this is all part of a complex framework which is for online shopping, right? So let's say this is our complex piece of online shopping framework library, right? So, and then this is a facade. Easy buy is a facade, and this could also be a class. And in this, we have a method, which is buy method. Right? So I'll put here, and then yes, you have a public buy method. And this is implementing all these, it is calling all these methods. So it's say having the logic, right? So let's say it is having all the logic, and then here it is maybe making calls. So this is if check state is stock, assume this returns, right? It returns true and false, then it provides next steps, right? If its stock is there, then you say check price, right? And then you will calculate amount, etc. You have lots of logic here, right? So this is all about your facade pattern, right? So yeah, let's call this buy, or yes, online store. Better name will be online store facade, right? So this is the name of this class, and it has few methods which will perform all the complex logic. But yes, application need not have to worry about everything. Application, your client, say web client is another class, right? Similarly, you will have other clients as well. So here it does not have to worry about everything. What it does have to worry about, it has to just create a object of facade, right? So we say online store facade, and let's call this object as say client or whatever. Yes, you may just call this anything, and you just say new online store facade, and then you say client dot buy, right? You buy a product. That's all. So it is very simple for clients to write this method, right? Basically, yeah, this is assume public. This is the main method, right? So you have, this is your web client, and correct. So this is just an example. Now you will say, okay, it's a web client, so why to have main method? Yeah, okay. Let's call this client, right? So some client could be there, and which is making this call, right? So if this is client, we can name it something else. Maybe we say facade, right?
So instead of making multiple API calls,
Yes.
he will make a call to one API, and that
Yes.
will call a facade.
Yes.
And the facade will call the main classes, business classes of all the other API.
Yes, yes, absolutely. Right.
Okay, if some of the API is from a different service, can that be in the here all the classes which you have mentioned, those are part of a different APIs, basically, right? Those are the business logic for different APIs. Come down, yeah, here product is there, shopping cart is there, and payment processor is there. Every individual class, this logic is associated to one API, right? One API.
Yes. Yes.
Yeah. And like if two of the APIs are for one service and one API is from other service, then can we also make facade out of that?
Yeah, you can call even external service also, because maybe you have to say take payment in currency. So if you want say currency converter, right? Maybe this is some external service. You may just call say currency converter service, right? So you may add some specific. It's up to you, right? Correct. So something could be outside also, but finally you provide the functionality.
Yeah. Okay. Got it. So for the
basically
API,
the goal is to simplify
yeah,
the life
understood.
of a developer. So you can do anything to simplify, and you can call more methods you call. See, the problem here is you have to take a trade-off. That's what I have written here. It involves abstraction and coupling. Yes. So when you add more methods here, you get tight coupling, right? When you get tight coupling, what is the disadvantage? There is less flexibility. Yes.
Yeah. Just wanted like last question regarding this. So in this class, we are making calls to the other classes and some external APIs of the different service.
Yeah.
Now, can I make a API call of the same service from that service? It's not possible, right? And it doesn't make sense. Huh?
Service.
Let's say a service A is there,
Yes.
and it has API 1, API 2, API 3.
Yes. Yes.
And I have created a facade, and I am hiding it under API 4.
Okay. Okay.
And a call is made to API 4, and it will trigger the facade of the API 4, and the class of this facade class, instead of calling all the classes of other 3 APIs, can it directly call the APIs? It's not possible, right?
Yes.
Because they are in the same class. They're in the same service. Is it clear or is it confusing?
Right. Okay. So you are saying, can the client call directly the methods here? Is it?
No. In the facade class, I'm talking about like in the facade class, we are making calls to the classes.
Yes.
Yeah. So come here, like here in the product, we are making a class call. We are creating an instance and we are making, right?
Yes.
There will be an API associated to this from the facade class, and that API is part of the same service.
Okay. Yeah. Yeah.
So instead of calling that method class directly, is it possible to interact with the API? It's not possible, right? Because it is in the same service. There won't be any HTTP call.
See here, this is all local calls, which I'm doing, right?
Yeah.
When we discuss design patterns, it is all within the same system we are discussing. This I told in the singleton pattern. Because singleton pattern will be singleton if you are working in the single server environment. So assume this is all executing in your current system, right? All this we are talking about, maybe we will cover once we will discuss distributed system and microservices architecture. So here everything is local. So there is nothing called remote here, right?
Yeah. Got it. So just my question is,
so yes,
if one API of one service and is calling this another API of the same service, it's not possible. So this is the doubt.
One API of a service can call another API of any service, right?
I mean same service. Let's say service A is there, API 1, API 2 are two parts of the service A.
Yes.
And I wanted,
there is a class, right? So in you always have a class in, we are talking about code, right? Single system. So you have a class. So you have class 1 and class 2. Okay. So yeah, this is our class here. Okay, one more class I got here. Yes. Tell me. Yes. So you have a class 1, class 2, right? So yes.
Class 1 and class 2, instead of class 1 and class 2, can we call it as API 1 and API 2?
Yeah, you can call anything. How does it matter, right?
I
So
mean, the request will matter, right? For the class,
yes.
the input should be in terms of objects, but for the API, the input should be in terms of JSON or XML, right? So
Yeah, but here it's all about methods, right? So why would you need JSON and all, right?
yeah, just wanted to understand. So like one API of the one service is calling the other API of the same service. It's not possible. We should directly interact with the underlying classes. That's the thing, right?
Yes, yes,
Okay. Yeah,
absolutely.
that's
Absolutely.
my doubt. Thank you.
Right.
Sorry.
Correct.
Yeah.
Yes, awesome. Nice. So yes, let's move on to other patterns, because yes, we will cover other patterns. So let's talk about the other two patterns. Yes. Let's talk about adapter and bridge pattern, right? Because I'm just covering the easier ones first, and then as we move on, we will cover more complex ones, right? So we will cover another one, which is the adapter pattern, right? Maybe as I will be covering more and more design patterns, many of your doubts will become clear, right? So let's talk about what is an adapter pattern. Yes. So this is adapter pattern. Adapter pattern is, now we talked about, we have one implementation, right? So assume we have, let's come back to our chess example. Chess example is a good example where we can use lot of patterns inside the application. So you always have different kinds of interfaces, right? You may not have all the same kind of compatible interfaces. So in case you have incompatible interfaces, then the pattern, the adapter pattern is the pattern which will take care that you will be able to use things in a proper way, right? So let's say, let me give you some. So, right. So let me get the chess here. There is, yeah, this is the chess game, right? So chess game is all about, we had two users, two players. We decided that we'll have two players in the chess game. This is get have another place is another play. We have some methods, which is move method. So player will call the move method. It will move. So it may take argument like chess piece. And it will start available to make a move for this particular player. Player is a real human. He will drag something and actually they will happen. right? Play. We don't want the player, we want chess to play the game. Right? So here, chess engine. Right? So that means you make a move, you are playing against computer, right? Available in the chess, you have to your current, yes. But yes, here you don't have this exactly. So in the chess engine, when you are making a move, you don't have this exact method, right? Maybe you have some other method in this case, correct? So let's say in this, there is some other method, which is what we can call. That particular method could be maybe called so here, let's say this method is called, say, make move, correct? So because yes, this is done by someone else, and maybe this has some other yeah, definitely the chess piece class will not also be there. Maybe it will just take a string as an input, right? And yes, so you remember we used a string, and this is your maybe chess piece, whatever is the piece, right? And then you have a start position again will be string, and here is string. So it's start and end. I'll get this all in the same screen. Yes. Start, and then finally you have end. So this is your method. Clear? See, there is a different kind of interface. So chess engine has something called make move method. And here you have chess piece class, and then start, and this is integers. Start is an integer, and is integer. You may have how would you represent a chessboard? This is another interesting question. Correct? So can you represent it using array? I mean single dimensional array. Or you need a two-dimensional array. What you will choose?
Two.
Pardon?
Two dimension.
Okay. Okay. Why not single dimensional array? You can use, right? You can convert a two-dimensional array to single dimensional array also.
But accessing is tough, right? If you want to access based on the row and column, it will be,
there could be, yeah, simple calculation. Into 8, the cell number, right? Got it? Yeah, so you can number all the cells 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like this, right?
okay.
Correct?
I wanted to get
So
like 4, 4. How can I get?
also be 4, 4.
4 by 4, row is equal 4 and column is equal
Fourth
4.
row and fourth column, right?
Hmm.
So you know here that this number is 0, 1, 2, 3, 4, 5, 6, 7, right? Then 8, 9, 10, 11, 12, 13, 14, 15, right? So every column here, so when you say fourth row, so that means into 8.
4
4
into 8
into
plus
8 plus column number,
yeah.
right? So
Maybe 2D also under the hood does the same.
Yes, absolutely, right? So row number and column number, right? So you can do this way also, correct? So yeah, maybe You may have a array as an input or a single integer also as an input. Yes, because yes, a lot of people make this mistake. If they have to design, say, snake and ladder, they choose two-dimensional array, and a snake in ladder game, it becomes very complicated if you're using two-dimensional array, because in snake you always move linear, right? And because in a snake and ladder game or ludo game also, you always move ahead or backward. You never move in two dimension, but in chess you move in two dimension. You move straight and you move diagonally, you move horizontally, vertically, lot of different places. So it's up to you, whichever way you can find it easier to do it. But yes, I would suggest in chess, you may consider using two-dimensional array. But again, this is again a good design consideration. In 2x2 board games, you can sometimes also simplify the implementation by using a single dimensional array, right? Clear?
Yeah, actually, this perspective is good because I have
Yes.
seen a problem, DSA problem, where we need to traverse in terms of like border array. Yeah.
Yes. Correct. Yeah, there could be different kind of traversals,
Yeah,
spiral traversals, and so which you should be comfortable with all kinds of traversals and all kinds of representation. This is different ways of abstracting the behavior, right? So
nice.
now coming back to our adapter class, right? So here adapter class, what it will do is it will, again, this is, as I said, is slightly less complicated. It's also simple, but it's slightly more complicated than the facade pattern, right? So in adapter pattern, what you do is basically you have a class which is chess engine class. This is your target class, right? You can call this is the target class, because you have to integrate into the chess engine. You have a player class, right? This is the source class, correct? Because the reason is your code for your application is written using the player class, correct? So what you can do is you can, source could also be called as adaptee. Yeah. So if better to use this terminology. So what you can write is you can write an adapter class. Yes. So here, let's write the chess engine adapter right here. So this is chess engine adapter. Okay. This is what you will write. And if you write this, you will be able to integrate the chess engine into your game, right? So now what is your, we have a little bit complicated it because we have here a string and different data types, but yeah, sometimes even simpler. So the way you will write it is, you have here chess engine adapted, right? And in this, when you have to call, say, when you have to make a move, right? Move. So basically, you will create a chess engine object, right? And in chess engine, you have to call make move, right? But yes, how would you call make move, because you don't know? So you will because you know how to make a call to the player.move method, right? Because you have to talk with each of these two implementations should be able to talk with each other. Yes. So what you can do is chess engine. This is chess piece and start, and yeah, you have a lot of other, yeah, so sorry, it's make move, right? Chess piece, start, end. Yes. Now, when you have this call, there is an adapter with a method here, right? So basically what you do is, you know how to call player method, so you pass the same signature here. Yes. And internally you map the call to chess engine method, right? So maybe you do that calculation, figure it out. What is the value? Say, for example, if I put here chess piece, if chess piece dot type is equal to knight, right? Maybe here, in this case, a string chess piece is equal to k, right? Maybe here they use a character in chess engine. And then if say you have position, start position is 1, right? Let's say start in this case is 1. So if start is equal to 1, so basically what it will map to is, in the chess engine is start parameter, this will map to A1 string, right? So you may write a function which can convert like this, right? And then finally you will have this particular call executed. So this is your adapter pattern. So you write a pattern, adapter pattern, adapter, and adapter takes care of translating the request, correct? And then finally, so you have here, if you see here, if I draw the class diagram here, then this will be much more clearer to you. So you have this class, which is player class. Then you have another class, which is chess engine class. And then you write a adapter. So you have a adapter. Adapter will take care of making the call. So assume the method which here we had was, this is called make move, right? And yes, it has some data. We call it spatial data, right? Data, yes. Here we have a method which is called move, and it has some data as the parameter. In the adapter, what you do is, you will have to have the interface of move should be calling data, yes, and definitely this will be having an object of the player class here. So, sorry. So you will, yes, you will have here, see, you will have an object of chess engine class. And you will call the same method, but inside this, you will call this particular right? Let's say this is private, this is public. So public and private are denoted in class diagram like this. And yes, you have this adaptive class. So basically, if you see here, you have an interface here. Adapter interface will have the interface of the client. So this is your client. Basically, client, this is what you are integrating with. So you will have to have the same interface here. Okay, to copy paste like this. Yes. So your interface, this is, we can call this is client interface. Yes. And this is interface. I'll denote like this. And this is exactly the same interface. So you make a call to the client interface. This client interface is implemented. I'll use the exact arrow. Yeah, this is implemented by the adapter. So this is implemented by the adapter. Adapter is dotted line always. So this is your implementation. And then you finally make a call to the service which you want to connect to the target. Right? So this is all about adapter design pattern. Simple? Because yes, you would have seen this adapter pattern in many places. For example, assume one class is taking input as maybe XML, other class is taking JSON, so you will write an adapter. Clear?
Yeah. The arrow which you are telling from players to interface, does that mean that the definition of the move method is same as the definition of the player method?
Arrow means yeah. So in this case, arrow is yeah, the client. Yeah. So let me think about this. So yeah, this is the implementation. So what you can think of, this is the implementation. Client is making a call to, okay, yeah. Right, you are right. So basically I should have drawn it like this. Or yeah, let me keep this arrow direction same. So yeah, the player also implements.
But it need not to be, right? Like
Yeah, because why it has to? Because your chess program in this case knows only how to chess game knows how to interact with the player. That's why.
Okay, I'm getting little confused here.
So if he knows how to interact with,
yeah, so my doubt basically is for the player, okay, this is adapter. Okay, adapter is okay, okay. Okay, okay. The adapter method, move method definition should be in consistence with the player definition. So that is the reason why we need interface. Only that for that purpose.
right. See, I'll explain in detail again. Yes. Let's see here. You have here the business logic. In player class, you have the business logic, which is making the move. Absolutely understood. So when you call a player method, it is able to move the chess items in the board, correct? So chess game or the player game is having the logic, business logic. This interface provides the protocol in which how you make the move, because this is the data which you have to pass. Correct? This is a service which will probably give you the move, right? This is the service which you want to access. Because chess engine is what you want to integrate. And this is a third-party service. Clear? So adapt class is something which the client can implement.
Yes, exactly. In the code you have wrote in the up, once go about that. Without the interface also we can achieve the adaptation, right?
Yes.
We can just make a call to the adapter class, and there we can get the data from the player, and we can convert and we can send the data to the chess engine without interface. So my question is about, I understood what the pattern is doing. My question is why we need to have an interface.
Yes, right.
And one more thing,
you need to have the interface, but yes, generally it is good idea always we say program to the interface. Yes, not to the implementation, because assume you have different kinds of players. Yes, so if you have the interface, you can have the adapter for all different kinds of players. Yes.
we have only two types of players, right? Black and white.
Yeah, black and white. No, yeah, black and white are two different kinds of players. But assume you may have different kinds of implementations for this interface. Yes. In some scenario, you may have that.
Okay, then my doubt is,
that's why I use the player interface. Yes.
Yeah, player also has other methods, right? Not only move, like
correct.
Check.
Yeah, it has
something like that. Let's say we have other methods.
Yes.
Then do we have to create for every method? Do we have to create an interface?
No.
Then where the other methods? Why there is no interface for other methods, and why we only have for move method? Like, so this is confusing. Like.
Right. See, you don't have to put all the methods into an interface. Yes. And why we have for the move method? Because this is the method which we want to use in the chess engine class, because this is something which is we have to make it compatible with the chess engine class. There may be a lot of other features also. So whatever you want to integrate, that one you will have this, right? So understood?
Yeah, but just like some
Because your doubt I understood. Your doubt is more relevant when to use interface.
yeah, exactly.
What
And
methods to expose as an interface?
exactly, yeah. What
Okay.
in the interface, how
Yeah.
many methods should we?
Let's talk. This is all about object-oriented design. Yes. Assume you have a class, right? So when to use class and when to use interface? First thing is, let me ask you this question. When do we use a class? When do we use interface?
Class firstly I will tell for interface we have some set of different
Yes, you have the
declarations.
definitions. Yes.
Yeah, we know the definition or declaration.
Yes. So in class, you have definition. Here you just declare. Yeah.
Yeah.
Declaration, right? So that means you have the signature.
Yeah, and that yeah, signature, and the signature can have many definitions. So to generalize, we use interface.
Absolutely right. So here you have implementation. Right. So now, so you may have implementation, and here you can only have signature, right? Now, there are many methods here. Right? So you have, let's call this as a class A. Let's call this a interface A. Yeah. And we have many methods. So we have definitely implementations of all the methods. And here you have signature. Now your question is, out of all these methods, which one to put in the interface? Right? Should I put all the methods in the interface? Yes. Now, maybe this method is very stable. This may be something which will not change. This is something which is frequently changing, right? So assume this is stable, right? This is stable. And this is likely to change. So what we will do, you will put method 1, method 2, or you will put method 3 in the interface.
Yeah, method 3.
Yes,
yeah,
correct. Because what is the advantage if you put here method 3? Why not?
yeah, just thinking about that only. We have put, it is changing a lot of times, implementation is changing,
Yes.
and now we have kept it in an interface.
Yes.
What benefit we are getting?
Yes. I'll tell you. So don't worry. Right. See here. Assume now this has changed, right? Now this has changed. In this case, if you don't have here this method, so you have to modify class A. Yes, you have to modify. When you modify, you have chances of regression bugs. Correct?
Still we are let's say it's changing. Still we have to change the method 3, and that is again in the part of the class A, right? We have the change has to be in the class A only again.
Yes. So what you can do is now you can say this is likely to change.
Okay.
Version 1.
Okay.
Here, version 2. This is new class A. See, this is the advantage.
So new class is implementing the interface. Old class is not implementing the interface.
Both are implementing.
Both are implementing.
Yes, yes. Because you have extracted the method out of this. Yes.
Okay, let's compare this way. One class is implementing and one class is not implementing.
Yes, yes.
If in that case, what is the cons we are getting by not implementing? What is the pros we are getting by implementing? Yeah.
Right. See, yes. See, the important thing which I taught in the first class, which is program to interface, not to implementation, right? Now, method 3 you have to call. How will you call method 3? You will call class A, say object new class A and object dot method 3, right? This is one way of calling method 3. Yes. So in case now the new implementation has come and you have to implement version 2. So you have to change this code, right? You see, I'm changing. Here I'm changing this code, right? So basically I have to insert new here, right? Insert new here, insert new. So I have to change it, maybe multiple places. This object creation, right? But yes, apply Liskov substitution principle and put here interface A. Create an object.
One doubt, like before that, why we are changing the class name? If the method name is changing frequently, let's say we have method 3 and we are changing the implementation of the method 3 inside the method 3, right? The changes are inside the method 3. If the changes are there in the
sure. So how about others? Are you guys understanding? You are able to understand? So Anil, Raju, Ramesh, do you understand when to use interface, when to understand class?
No, sorry, I didn't. Actually, I was having a meeting, so I joined a little late today.
Yes.
So, yeah.
No, my question is, when do we create an interface? When do we create a class? This is
Okay, so interface basically like if we want my classes to implement whatever method is defined in the interface, in that case, we are going to actually do that. But yeah, I mean, it's kind of, we are defining there in interface and then same will be implemented by the class, child class.
Yes, but yes, what is the advantage of doing that? What is the advantage of creating an interface? Basically,
it's kind of typecasting. Let's suppose if you have super class, right? So basically, we can pass the super class.
But
how we
what is the advantage of that super class? To a programmer, what is the advantage of super class?
Basically, let's suppose we are passing something like parent, right? And there is a many childs. So basically, we can have a type of parent and the method defined, and then it can be object created and further it can be.
Yes, right. See, this is, you can program to interface, not to implementation. Yes. So this way, you may have any number of implementation, only method 3 is changing. Method 1 and method 2 are the same. So you don't need to put this in the interface. You may just inherit from the same base class, but things which are changing, you put it in the interface and program to the interface.
So like that interface provides the flexibility for different implementations, right?
Yes, it provides the flexibility for different implementation. You can replace the implementation without changing the code of the client.
Right. Okay,
right. So that is the advantage. Now, this is what is adapter pattern. So we now understood the adapter pattern. Correct? Don't worry. I will be covering more patterns and these are related patterns and you will be understanding this more thoroughly when we will be covering another patterns. So your doubt clear, Arun? Right? To certain extent.
To a certain extent here, like when we wanted to change, let's say we have vehicle class, if you wanted to bike or in something car, if you wanted to change, that way it will be decouple. Or else we can take a phone, in the phone we can have different type of chips. If we have hard coded for Snapdragon or Qualcomm, then it will be hard to replace. Instead we program for chip, it will be easy for replace. That part I understood, where we do that interface. But here in this place, in this scenario, we are using the interface, right? And it has one method. So like, okay, I will just think thoroughly. Let's continue because it might take more time. Yeah.
Right. See, yeah, you can also discuss this later. I'm not implementing again. It has changed. I was forced to implement because there is something new has come up in the environment, right? Take that example of bulbs. The adapter was same, the interface was same, but earlier there was the asbestos wire bulb where that filament used to heat up and then the light used to come. Now LED is there, right? So they have programmed the socket to the interface. So as things change, since you're programming to the interface and your interface is not changing, you will be able to deal with different implementations. So this is the reason why we can do this, right? So even if you change it, need not have to change an existing class, you can always create newer implementations and your existing code will be compatible with old implementation as well as new implementation, right? So now let's move to the bridge pattern.
In this case, what is the client and what is the in this interface? What is that client?
Which is black?
In this one.
Yeah, the client is another object which is using this class.
Okay. Continue.
Right? Client is someone, could be main class where you are calling these methods. Yes. So bridge pattern, but yes, good. I will advise everyone, if you have even a minor doubt, even you feel no doubt is a stupid doubt, and you should clarify each and every doubt, because when you will be giving interview, you will be drilled down. The interviewer may go into any detail and ask you to explain each and every decision to any depth. So you should understand this thoroughly and should be able to explain to the interviewer, right? So, but yes, you should also have the confidence to design anything. Now, I will give you an exercise, which is bridge pattern, right? Let me talk about bridge pattern. Bridge pattern is also very similar to adapter pattern, almost the same. So let me give you another example. This will explain you. Are you hearing my voice properly? Because yeah, I see Arun was complaining about internet issue or my voice is getting broken.
Yeah, still now there is some breakage in your voice. I am feeling that.
Your feeling. Okay, how about others? Are you able to hear the breakages or not?
No, it's clear.
Is clear? Okay, maybe at your end there could be a problem. Yeah, because I see others are able to listen. But yeah, feel free to tell me when there is problem with my voice. I can repeat. But yes, you can view the recording or see if you can switch the internet connection. Maybe nowadays your hotspot is very fast. They provide good experience if you have Airtel connection. Okay, so now let's talk about the bridge pattern. I'll give another example for the bridge design pattern. We discussed that we would like to have a option in our chess game that we can leave the chess game, we can store the state of the chess game, and later time at some other day can come back and play the game again. Right? So assume we write an implementation which saves the game into a database. Say, let's say we save the game to MySQL database. Can do, right? Because maybe in the database we can store that what all users are playing, what are, how many moves have happened, and we can store all the information so that it could be retrieved later and we can deserialize from the database. Right? Or you can think of, or from file also we can deserialize. But yes, since there are different kinds of databases, I'm using this example because files are always same, right? So, but yes, XML or JSON I can use as an example. So that could another be example. So yes, how, let's say, yeah, what we are doing is we have a bridge pattern. We have this situation that yes. Let me write now more thorough code so that you guys people understand. So the problem you got is, let's say we are storing, doesn't matter. So let's say we are storing all information for the chess game, stores state of game in MySQL database. Right now, there is another person who came and he asked, okay, I'll pay you some more money, and if you can develop the same chess game, but you have to store the database maybe in MongoDB, right? Database. But yeah, don't worry, I'm not covering the database detail. I'm just using some example. MongoDB database. So now new requirement. This is your second thing, is your new requirement. Right. So basically what you have to do is you have to write you can write an adapter also here, because you have an implementation for MySQL. You can write a MongoDB adapter and you can also get the implementation for MongoDB also, right? So your chess game will store information in the MongoDB, and you may write adapters for all the databases, and then you will get a version which will work with all the databases, right? So this is how you will program so that your application can work with any databases. So basically here we are considering how to make our application so dynamic or so generic that it can work and integrate with any kind of databases. So there are two approaches. One we saw, which was the adapter pattern. This one is the bridge pattern, right?
Adapter and bridge pattern are solving the same problem, right?
Yes, absolutely. They're solving the same problem.
Then, like, when,
yes,
if the problem is there, which one to go with?
Yes, right. So you decide, but let's first see the pattern, right? Then you will understand which one to go with. Yes. Right. So bridge and adapter, they are two patterns. and both solve the same problem, that you have two separate implementations and how you can make these two compatible with each other, right? There is slight difference which I'll cover in this, and with this you will understand when to use. So do not worry, you will get the answer. But yes, if I give you answer, you will not understand now because you don't know what is the bridge pattern. Right. So let me put the classes here. I'll draw with respect to the class diagram so that this will become clear to you. Yes. So the way it is, how is your application designed, right? So you have here your chess game. This is your chess game. Chess game is connecting to calling the database. Let's say it has two methods. Save, it has, it has an implementation which is for MySQL, right? So let's call this is a class, MySQL database class. In this, you have two methods, save game, load game, right? And in this, in chess game, you have, say, assume one method, which is the main method. When you call, main method executes, main method will create a new database object, which is MySQL database. And whenever it has to save the game, it will save the game using the database object, and it will load the game if it wants to initialize the game again from some saved state, right? This is clear. So what you can do is, you will say, okay, what I will do is I'll write MongoDB, one class here, and I have MySQL class already there. So you will have this methods here. Yes. Yes. But yes, you have to implement this. So how you will do this? By creating a bridge. Right, so bridge, let's call this database bridge. Yeah. You should understand that these methods, although the name is same, but yeah, there would have been different implementations of this, right? So just to make it easy for you to understand it, I'm naming it differently. Here you have save and load. Correct? And you have an interface also here. You can always have an interface. You generally have always interface because that provides you an abstraction. Yeah. So yes. So basically you have a database class. Database class have the save method and load method. Yes. Database method will have here the bridge implementation. Bridge implementation I need to go into the coding level also to explain this better, because then only you will understand, right? So let me keep this for time being. So yeah, here, yes. Yeah. I will use here the inheritance. Yes, correct. So while designing, now my next question is, when to use abstract class, when to use interface? Anyone can answer? When to use interface, when to use abstract class?
There is any common functionality between multiple classes, then we go for the abstract class.
Yeah, if you have some default implementations, basically, if you have some something you want to pre-implement, right? Then you can go with abstract class. Yes, otherwise interface, right? So assume there is some, yeah, so there's very little difference between interface and abstract class. But the important thing you should understand is, now let me cover this threading also, just to make you think, make everything clear. There are two ways to create thread. One is using the new object, right? Thread T. And then you call T.run. This is one way. Yes. Another way is to make your class. So there are two ways. One is you extend the thread class, and other way is to implement the runnable interface in Java. This is how you can do this, right? So if you're working on some operating system level classes, right? Maybe you are writing some device driver. So you are creating some jobs. So you can say job extends thread, and then you can implement the run method. That makes sense because here job is a thread. But assume you are implementing some web application server where you are serving multiple requests and you want each of the requests to be served by different threads. So in this case, you say request extends thread. This is sounding wrong because here request is not a thread. Request is something else. Request is what you call a message. So here you can say request implements runnable. That sounds more logical because request is some other object which is unrelated object to thread and is a relationship. So whenever you have something where you don't have is a relationship, you use interface. In abstract classes, you always have is a relationship. So here database is maybe my database implementation is a, so here maybe you can think of, is it sounding like an interface? Database bridge is a database, or database bridge implements the maybe storable interface, right? I could call it something like this. So I would choose, if I have to make this decision, I'll call something like storable interface. Yeah. And my database bridge implements a storable interface, and the storable interface has save method and load method. Yes. So now here, let me quickly write the code. I have a main method. And in the main method, I'm not going into the details of, don't worry if I'm not writing string arguments or void main, etc. But yes, so you have database bridge. Here, let's call this bridge MySQL, because now we will be working with MySQL. So MySQL database. If I create this object, see, this is inheritance, correct? So I can put here. And then I have MySQL. Yes. So yes, this is what I wanted to demonstrate is different than adapter pattern, because here I have save method. I have an interface here, as I said, which is my storable interface. Yeah, so that's, again, I don't need to write it because it's obvious from here. I have a database implementation here, which is MySQL implementation. And this is important. This is interesting. You should pay attention here. This implements database bridge, right? And here I have saved my SQL, this method getting called. And logic for this. Now my bridge, how is my bridge implemented? This is my constructor. It takes yes, so something like this. This is the implementation of my database bridge, right? Clear? So now, did you got the difference between these two implementation? So here my main method is calling database bridge and this is and then I am passing MySQL here inside this and db.save. This is how my bridge will work. If I have to save to MySQL DB. If I have to save to the other DB also, just what I need to pass is I need to pass Mongo DB here. So MySQL database. This is how I named it. Now, the difference, the advantage here is, see here, I am doing here. So I can add some custom logic here also. So I can do some pre-processing, which was not possible in adapter pattern. So while integrating, if you want to enhance some of the functionality that you can do with the bridge pattern, which you cannot do in the normal adapter pattern. So this is difference between bridge pattern and adapter pattern. Are you able to understand this? So is your internet now working, Arun? Yes. So am I connected to the class or I got disconnected?
No, we are able to.
Yes, we are able to hear, right? So basically you should understand that, yes, if you have to implement the integration part by part, and if you even want to implement enhanced functionality, then you can create a bridge pattern. So bridge pattern is a pattern where if you have a complicated integration, you have integration at multiple levels, you can create bridge of small implementations, and this way you can kind of integrate using bridge pattern.
So, sir, what is the use of save MySQL method? Here we are calling db.save method only.
Yeah. Yes. So let me see this. Okay. So you have main class. Main class, you do the save method. And you are asking about when is this going to be called? Because this is bridge. Yeah. See here. Great question. So here actually, so your DB equal to base. This is something would have happened here, right? Because see, basically what I'm doing here is I'm passing here the object of MongoDB or MySQL database here. You see here, this is getting passed here. And db.save is the method which I have implemented. Yeah, db.save. Where is the db.save method implemented? Okay, I have not implemented it, right? So here there is a save method which I have to implement it. And in this, I'll have the logic. If my DB is instance of MySQL database. Then I will call save MySQL, this method, right? Else, based on whatever is the implementation, I may call different methods. Right? So something like this will be the implementation of the save method, which is again save method. This will take the database object, which is passed to this particular method. Yeah. So now clear how is this going to be called? Yeah, because this is how it will be there, right? See, the complex patterns are getting complicated. So that's why I was slightly lost, because how to implement it requires thought process. And basically the idea you should understand that there are two things to be taken care. Yeah, let me summarize the differences, because then only it will be clear. Otherwise, it's hard to explain, because these are the concepts which will come while you are implementing it. Yes. So we saw two things. One is your adapter pattern. Other thing is the bridge pattern. Right. So in adapter pattern, what you do is you convert the instance of class into another interface that client expects. This is how your integration happened. Yes. In bridge method, what you do, you decouple. We are doing decoupling. You see here, using an abstraction. From its implementation. Yes. Right. So that allowing them to vary independently. Right. So this is the difference. Basically, yeah, this next line is not necessary. So convert instance of class into another interface, right? That client expects. Here decouple expectation from in implementation. Here basically you are wrapping what is you're writing is a wrapper. You would have seen various wrapper classes. Adapter is nothing but a wrapper. Bridge pattern, basically, yeah, bridge pattern is connecting two separate hierarchies, right, to work together. This is what is bridge pattern. But yes, I tried to do the same thing by saying that, yes, I have here a database class. And then I have here MySQL class, and I have MongoDB class. So you have database, and then you have MySQL and MongoDB. So this is the hierarchy we are integrating. Maybe we have a file also. But yes, we are allowing all these hierarchy to implement to get working together using bridge pattern. So basically what you do is you abstract out and create a bridge. And bridge takes care of decoupling and then calling. Yes. And wrapper is nothing. Wrapper is just having the same interface and you are calling here. So basically bridge works with the database, and then it provides an abstraction, and we can connect and call various methods depending on what kind of implementation you have. You may call, your client may be getting that required functionality. So this is the bridge pattern. Now adapter has the interface. So basically, if you see here, you have a bridge. Bridge is a generic implementation, right? And then you have more specialized implementation. Generic implementation here, this is generic implementation. And bridge is nothing, bridge is the abstraction. Yes. So this is how your bridge pattern is implemented. Your client is always dealing with the abstraction. This is how it is integrating. Basically, yes, you have solved actually different problem here. You are not only solving the problem of incompatible interfaces. So here, basically adapter is what is, you have two incompatible interfaces. In bridge, you have a hierarchy of various implementations which you want to integrate. So here we saw that, okay, in adapter, you have the service and you have a implementation which is wrapping around this service. Okay. So this is adapter. Is this clear? The difference between, so Anil, are you able to understand the bridge pattern?
Yes, sir. But I have one point, I mean, one doubt. So
Yes.
we can have this call this specialized implementation by calling that database also, right? So why do we need this this bridge of abstraction?
Yes. Yes.
That point, I understood the pattern, but this was like when I thought it got stuck in my mind.
Right. Right. So the point is that why do you need the abstraction? Because that's why I draw the file. Yes. Because database is your generic implementation. Abstraction is about loading and saving of the information. And there could be another generic implementation, which is about the file. And then there could be specialized implementation of various hierarchy of different kinds of file storages. Yes, let's say simple file and distributed file, maybe Hadoop file or various other implementations.
Okay, so the bridge interface specifically does the abstraction and the steps for initialization, right?
Yes, yes,
Okay,
yes.
so in order to make this more friendly, we used the bridge.
Yes, yes, correct,
Oh,
correct,
okay,
correct.
got it.
So you can think of that. This is the hierarchy. There are multiple hierarchies which you want to make work together, right? So in our chess example, we are storing information in the databases, we are storing information in the files, we are storing maybe in various other kinds of mediums. So with bridge pattern, we can achieve that because maybe file has to do more things. Maybe we have to provide path, etc. So that is the specific implementation. In database, maybe we have to provide tables, etc. So that is again a specialized implementation we need to write, because yes, in MySQL, you need to provide the table schema, columns, etc. But in MongoDB, you may have to provide the document, right? Cluster ID, etc. So that could be the specialized implementation. Yes. So this way you divide the integration points and then create abstractions out of each of these layers. Probably, yeah, maybe I could not give you the right example because I tried writing the code, but somehow it needs more practice. But yes, I'll share some code. So this is my action item that I will give you very easy to understand code that will highlight the difference between adapter pattern and the bridge pattern, right? So I'll do that in next few days, right? Over now there is a weekend coming up. So yes, before Saturday, on Saturday, I'll do that and share it across before our class so that you get good understanding with real example, which is easy to grasp. Because I tried doing it, but yes, this is yes, split into multiple places. So I will reorganize it and I'll share you across two files. One is the adapter implementation, other one is bridge implementation. And when you see this side by side, you will understand it. And this is basically difference between bridge and adapter implementations. And this is adapter pattern, and this was the bridge pattern. So this is the class diagram wise separation between adapter and bridge pattern. So today we covered three patterns. Yeah, it's turning out that we are covering three patterns per class. Yes, but yes, the other patterns which we need to cover were proxy, flyweight, decorator, and composite patterns, right? So yeah, proxy, flyweight, decorator, comparator pattern. Yeah, we covered bridge pattern also. And decorator, composite, flyweight, and proxy patterns are the patterns which we need to cover in the next class. And then we have to cover the behavioral patterns. Behavioral patterns are, some patterns are easy, some patterns are complicated, but yes, probably I will share the presentation, because if I keep giving the code examples, it will take a lot of time. But yes, next class, maybe I will pre-cook all the examples and then just share it across as a PPT so that it will be faster in the next session. But yes, next session do attend, and it will be an important session because we'll be covering many of the patterns, and behavioral patterns are even more important. Yes, so you're clear. So adapter pattern should be very clear, and bridge pattern, I'll share an example. But yes, we did this adapter pattern really with detail with code examples. Hope that is clear. And bridge pattern, I'll share another code example. Arun, any other questions?
Yeah, nothing major. Yeah.
Yes, so basic difference between bridge and adapter pattern is, adapter is just to integrate two interfaces, two different components with different kind of interfaces, as we saw. Whereas bridge pattern is for integrating hierarchies of different kinds of classes. Yes. So probably in the next session, we will cover the remaining patterns. Okay, have a nice evening. Goodbye.
Bye, Tarun.
Thank you.